Alright, this video is about solving trigonometric equations. These are the identities that you need to know for solving trigonometric equations. Alright, here's an example for simplifying a trigonometric expression. Now for starters, what you want to do is you're going to pull out a tangent from this here. So pull out your tangent squared, x, and then you're going to this simplifies into 1 minus sine squared. And this can also be further simplified into cosine based on our identities earlier. Then this can be simplified further into sine squared x over cosine squared x. And this can be simplified by that. These cancel out. And you're left with sine squared x.
Okay, so for the next problem, we're going to be asked to simplify cotangent theta times secant theta. So we start by knowing that cotangent theta is the same as cosine theta over sine theta, and secant theta is the same as 1 over cosine theta. So then we plug in these identities for what we have up here, and we get cosine theta over sine theta times 1 over cosine theta. These two cancel out, and we're left with 1 over sine theta, which is the same as cosecant theta.
Okay, hey everybody. Today we're going to be simplifying this trigonometric expression. We're going to be adding the two and then simplifying it down to its base form. So the first thing we want to do is make sure the denominators are equal on both sides. We're going to multiply on this side by this coefficient, by this expression, and on this side by this expression. So we're going to have 1 times 1 minus cosine of x over 1 plus cosine of x times 1 minus cosine of x. Then we're going to add that to the same thing on the other side, except we're going to be multiplying by 1 plus cosine x instead. So 1 times 1 plus cosine of x over 1 minus cosine of x times 1 plus cosine of x. So now let's simplify down the expression in the denominator. So you have 1 plus cosine x times 1 minus cosine x. We are going to FOIL. So you get 1 plus cosine x minus cosine x minus cosine squared x, right? So these will cancel when you add them together because it's positive and negative. So you have 1 minus cosine squared x. So let's put that back in to our equation because now we have finally simplified down the denominator. So the top will basically be the same just because you multiply by 1. So it's 1 minus cosine of x over 1 minus cosine squared x plus 1 plus cosine x over 1 minus cosine squared x. So now when we add, the 1 and 1 become 2. The cosine, negative cosine, and positive cosine will cancel themselves out, and left with 1 minus cosine squared x. Now if we remember our fundamental identities, we remember that sine squared x plus cosine squared x equals 1. So if we subtract the cosine squared x, we get it equals sine squared x. And that's exactly what we have here. And so we're going to substitute this in for a sine squared x. So 2 over sine squared x. Now we can also simplify this further because we know cosecant equals 1 over sine x. So we can simplify this down to 2 cosecant squared x. And that is how you would add or subtract expression with trigonometric identities and simplify it down to its basic form. Hey guys, alright, right now we're going to try and prove this identity. So we have tan squared theta over secant theta equals sine theta times tangent theta. So we're going to use the two top identities, secant equals 1 over cosine and tangent equals sine over cosine, to help prove that this equals this. So the first thing we want to do is bring that secant up to the top. So we're going to rewrite it as tangent squared theta over 1 over cosine theta, because we're just substituting the secant in for 1 over cosine. Then we're going to multiply by the bottom, so the inverse, to get it canceled on the bottom. So this would be tangent squared theta times cosine theta over 1. So it's over 1, so it's the same thing. So just tangent squared theta times cosine theta, right? Okay, so right now we're going to simplify the tangent squared down using this identity right here. So it's sine squared theta over cosine squared theta times cosine theta, right? We'll cancel one of the squares and one of the cosines. So now we're left with sine squared theta over cosine, right? So now what we're going to do is we're going to take one of the signs out of the top. So we're going to rewrite it as sine theta times sine theta over cosine theta. And that is just tangent. So now we're left with sine theta times tangent theta, which would equal sine theta tan theta. And that is how you would do this kind of problem.